We're going to explain friction now. We have a table and a book on top. The two surfaces, when opened up and zoomed into, you can see that the surfaces are actually a lot more bumpy than it looks like. When you zoom in even more, you see these ridges on each surface. When the ridges actually brush up against each other, it prevents from moving any faster, which is what we call friction. And the resistance to it is actually normal force. So there's static friction, which is the stopping or the right before you actually move something, and kinetic friction. It's when they're brushing against each other and actually moving the surface.
In our group, we said that Billy Joe Bob's statement about how his truck with more mass would have more friction force compared to a much lighter car. This is a correct statement because of Newton's second law. This is what a little bit of mass, in other words, the small car, would look like. It's much easier to move, not a lot of friction force. And the more mass you add, the harder it is to move, meaning his statement was correct.
This will show us how mass doesn't affect acceleration on a flat plane. We're going to start off with Newton's second law. F net equals ma in the x direction. We're going to substitute our net force for the force of friction, simplify that into the normal force times mu, and simplify that further into mass times gravity times our mu. And through our algebra, we can see that the masses cancel out, thus saying that that mass doesn't affect our acceleration. But our data contradicts this idea, showing an increasing acceleration with a larger mass.
All right, I will be explaining how mass does not affect acceleration on an inclined plane. First, what we did here in our free body diagram is that we flipped it, we rotated it so normal force was pointing up and showing that gravity is not pointing direct down. Now, once again, we're using Newton's second law, F net equals ma. Then we use simple algebra to find out that it is equal to Fg minus F of Fk, which is gravity and friction. And then once again, friction is equal to normal force times mu. And then we use our simple algebra and see that we divide m to find a, and they cancel each other out, meaning concluding that mass does not affect acceleration, and that but our data says otherwise. All right, so the coefficient of friction force is the roughness between both surfaces, as like the truck on the road or like our car on the track. Now, in our first experiment, our data actually shows that it does not support our idea, and that the coefficient of friction is changing. This is not physically possible, and basically that must mean we made an error or there's some outside force that we have not learned about yet. Now, in our second piece of data, we can see that it does support our idea that mass does not affect acceleration and that the coefficient of friction force does not change.
In our first data set, it shows that our friction coefficient is changing. This does not agree with the theory that mass changes acceleration. This means that our data set was inconclusive, or it's just something we haven't learned about yet. In our second data set, the friction coefficient between weights doesn't change. This supports the idea that mass doesn't affect acceleration.
Okay, so in conclusion, Billy Bob Joe's hypothesis is that he believes that because his truck is a greater mass, he will change the acceleration and slow down faster, as we believe mass has no effect on acceleration. Now, our first piece of data proves Billy Joe Bob's hypothesis correct, in that as we added different weights, the coefficient of friction would change. Now, and as our second piece of data on the inclined slope, our coefficient of friction or the acceleration stayed the same. This shows that either our data is pretty unreliable. Now, we looked into Newton's second law. Newton's second law stated F net equals ma, and after doing careful algebra, we can see that mass cancels out every time. Now, this proves our hypothesis correct, but of course our data disproves our hypothesis and agrees with Billy's hypothesis. So as from a physics standpoint, the really only conclusion I can come up to is that either there's something we've not learned about, or that our data is flawed,